Question 7. So we have to refer this figure. Determine the internal resistance R1 if the current that flows through the 10 ohm resistor is 1 ampere. Okay, so this is where we have to apply both Kirchhoff's first and second rule lah. Okay, right, so let's do this. So first thing I would do is pick a junction. So I would pick junction A, so we can then apply the first rule of Kirchhoff, which is total current going into a circuit should be equal to the total current going out of the circuit. Okay, so this is for junction A. So the current set going into junction A is I1 plus I2 equal to I3. So this is our first equation. Okay, and then the second one is we have to determine how many loops are there and designate a direction of the loop lah. Okay, so firstly I would do is I would label the direction of the EMF. Okay, so the direction of this EMF will be going to the left. Okay, and then this one is also going to the left. Okay, itu je. So my direction for the first loop would be anti-clockwise. Okay, so I will be designating the direction of this loop to be anti-clockwise. Okay, why? Because I want the first EMF to be positive, so that's why I follow the direction of the EMF. Okay. Okay, now after that apa lagi? Designate the direction, and then current sudah ada, so this one is going here, this one is going here, current is going here lah. Okay, so the current is based on the diagram. This is current I1, this is current I2 lah, and then I3 is here. Okay, then for this one the current will be ini di sini kan current dia. So this one I would put the direction siapa? This is the going up here lah. Okay, so this is I1 as well. Okay, boleh faham? Okay, let's do this. Wait, let me label them. So this is I1, this is I2, this is I1 balik. Okay, this is I1 juga. Right, so the first loop. Oh, and then the second loop kita buat terus lah. Okay, the second loop. So the second loop I would also want it to be anti-clockwise. Okay, so let's look at the first loop dulu. So Kirchhoff's second rule states that the total EMF should be equal to the summation of the product of current and resistance. Okay, so the EMF one, so this is positive E1, and then minus E2, so this is in the opposite direction, and then I1 R1. So let's look at this one. So I1 R1, and then this one is also positive I1 R1. Hopefully you get which resistor I'm talking about now. So I'm doing it what I'm doing now lah. Okay, so this one is positive I1 R2 lah. Okay, so betul ka sudah ni? I think it's correct. Yes. Okay, so this will be 15 minus 11. So this is I1 R1. R1 is the one we have to determine. So I1 R1 plus I1 R1 is 5 minus I2 2.05 plus I1 4. Okay, so simplify them, you'll get 4 equal to 9 plus R1 I1 minus 2.05 I2. So this is your second equation. Okay, now look at the second loop. Okay, so look at the second loop pula. So this is in the same direction, so this will be positive. So there's only one cell, so satu sajalah EMF dia. Okay, and then let's look at the one here going here. So this is, forgot to label, this is I3. Okay, so I3 is equal to I3, why am I rushing? So I3 are 3. Okay, they're positive sebab it follows the direction of the loop, and then I2 is also positive because it follows the direction of the loop. Okay, so that's it. So this is equal to 11. So this is gonna be equal to 10 I3 plus 2.05 I2. So what else do we have? So I3, it flows through the 10 ohm resistors is 1 ampere. So this is 1 ampere. Okay, so we have 11 equal to 1, 10 plus I2, 2.05. So we have current number 2 to be equal to 0.59 ampere. Okay, so now we can substitute I2 into equation number 1, which is the one shown here. Okay, so dari sini kita akan dapat I1 to be equal to 0.51 ampere. Okay, lepas dapat I1, we can then substitute I1 and I2 into equation number 2. Okay, oh yeah, equation number 2 because we want to find R1. So R1, dari the substitution, you'll get 0.76 ohm. Okay. Question 7b. So we have to calculate the current that flows through each of these resistors. Okay, so now we have to calculate the current pula instead of the resistance. Okay, but still we have to do the same thing. Firstly, we have to choose a junction and label the direction of the current lah. Okay, so so let me just choose junction C. So current flows from the positive to the negative terminal, so I would label it the current I1 to be going there, and then I2 would be pointing there, and I3 would be pointing here lah. Okay, so this is I1 and I2, I3. Okay, so use the first Kirchhoff's rule. Total current going in is equal to total current going out. So from here we have I1 equal to I2 plus I3. So this is your first equation. Okay, so we have to calculate each of the current that flows through each of the resistor kan. Okay, now the second Kirchhoff's rule, we also have to apply that. So firstly, let's designate the direction of the loop. Okay, so remember, EMF goes from the negative to the positive terminal, so I'll always label them so that I don't get confused whether it should be positive or negative lah. Okay, so that is the direction of the EMF. Remember, I also want the first EMF to be positive, so I'll designate the direction of the loop to be following the first EMF lah. So this would be anti-clockwise. Okay, do the same thing for the second loop. So this one, I'll follow this EMF. So I want it to be positive. I'll do clockwise lah supaya EMF 2 is positive. So this is gonna be clockwise. Okay. Okay. Now, from here, we can then use the Kirchhoff's second rule lah. Okay, so total EMF equal to total product IR. Okay, so the first loop, let's look at the first loop. So E1 will be positive, E2 will also be positive because it is following the direction of the loop. Okay, and then equal to equal to I2 R2 because it follows the direction of the loop, and the current will be going up here, and then this one will be pointing there. So this is I1 lah. Okay, this is gonna be I1 I1. Okay, this one current dia Di sini lah, I2. This is I3. I2, I3, so that you don't get confused. Okay, so untuk resistor 1, it is also following the direction of the loop, so I1, R1. So there's only 2 resistors, so that's it. So this one's gonna be 15 plus 8 equal to 0.7 I2 plus 2 I1. So this is your equation number 2. Okay, now let's look at the second loop pula. Second loop, so E2 will be positive. So E2 and then E3 will be negative because it is against the direction of the loop. Okay, and then let's look at the R2 punya resistor. So it is following the direction of the loop, so it is positive, and then I3 pula, it is against the direction of the loop, so it will be negative lah. Okay, so that one is I3 R3 lah. Okay, so there's 2 resistors, so that is the equation. And then this one's gonna be 8 minus 15 equal to 0.7 I2 minus I3 is 0.2 I3. Okay, so this is your third equation. Okay, so from here you can substitute equation 1, which is this one here, into any into equation 2 lah. Okay, into equation 2. Okay, so when you substitute that, you will create another equation which is equal to this value here lah, plus I3. So this is your fourth equation. Okay, so you solve that equation by adding equation 3 and 4 together. So you should get the value of I2 to be equal to negative 4.85 ampere. Okay. Okay, if I think so lah. This one I don't calculate. 3 plus 4 ni I don't calculate. It's based on the answer scheme sudah sekarang. If it's wrong, let me know lah. Okay, the negative value, it just indicates the direction of the current yang you designate here is wrong. Itu saja. Okay, the direction tapi the answer is still correct lah. Okay, and then I3 pula, and then substitute I2 into 4. So I think you should get I3 equal to 18.04 ampere lah. The solution for I1 is equal to 13.20 ampere lah. Okay, right, so that is the solution for question 7B.